Welcome, this is the Binomial Theorem. How did you use the Binomial Theorem to expand powers of binomials? Pascal's triangle is a famous number pattern. I just want you to play with this. Right now, I want you to switch down. This is the 7th lesson of Unit 3. Generating Pascal's triangle. In class, you came in and we just took this triangle and we just started looking at the patterns. 1 to 1, 1 to 1, 1 to 2. Well, see how both these lines come in? What operation did we do? If you said we add, well, you're right. Now just keep adding. Go down. This would be 1. 1 plus 2 is 3. 2 plus 1 is 3. And 1 is 1. Okay? Continue to fill in this grid. Pause the video and fill that in. You're going to need it. Okay. Now, it says, what are all the paths to get, a second, get my paper put in there. What are all the paths to get to the second node in the third row? Okay, write the paths in terms of left, right, and right, left. How are the paths alike and how are they different? Okay, so the second row, or second node, third row. So this is the third row, this is the second node. So that's the one that we're looking at. Okay, so if we start to write the path, I'll set this right here so that you can know, can't see both that way. Let me see how I can do it. Set it right there, how's that? Okay, so to see the pathway to this one, first off, I really like to write it as the third row, second node, just so that I can remember what that combination is. So I go third row, second node. Now let's look at all the different pathways. I could go left, left, right. So I could go left, left, right. We have to follow the lines. I could go left, right, left, left, right, left, right, left. Or I could go right, left, left. Okay? Oops, I did it backwards. Right, left, left. Okay? So you're just looking at which branch you're taking out of the box. If you're going to the right, you go R. If you're going on the left one, you go L. So we went left, left, out of those two boxes, then we went right. Or to go to this node, right here, we go left, right, then we go on the left path, going out of that box. Up here, we go right out of that box, then left out of that box, that one went right, left, and another left. So those are our different combinations, okay? How are they alike and how are they different? Well, how many L's do you notice in each one? You should write out that there's 2 lefts and there's 1 right in each pathway. Which node in which row of Pascal's triangle is located on the path? Okay, here we go. Left, left, I'm going to use a pen. Left, left, right, that would go that way. Left, and then right. So that would be the 5th row, 3rd node. So 5th row, 3rd node. And you should write it out. That it's the 5th row, 3rd node. I just like to keep the pattern the same. The value in position R of row N of Pascal's triangle is written as N, C, R. Okay? So This is the node number, the second one. And this is the row number. So like the second row is always the 2 is in the front, and then the position. I kind of look at it as houses on a street. This is 0 street, this is 1st street, so they're all 1, and then the number node from the left to the right is 0 and then 1, you just count them. 2nd street, see they're all on 2nd, 0, 1, 2. 3rd street, 0, 1, 2, 3. So you're just putting their order. Okay, there's some cool patterns with this. Now, try to get this paper laid flat now. Expand each power, okay? Anything to the 0th power is 1. Okay, a plus b to the 1st power, that means they're only going to occur once, so it's a plus b. Now, the perfect square, we did this in the last ones. A plus b, get a squared, plus ab, plus ab, plus b squared. ab plus ab would be 2ab, so it's a squared plus 2ab plus b squared. Now, if we expand with another one there, well, we can take this answer and we can multiply another a plus b, a squared, 2ab, b squared. A times a squared would be a cubed. B times a squared is a squared b. A times 2ab would be 2a squared b. A times b squared is ab squared. 2ab times b is 2ab squared. And now b times b squared is b cubed. Now we take all of these terms off the chart, so a cubed, over there in our answer, 2a squared b plus 1a squared b would be 3a squared b. ab squared plus 2ab squared would make another 3ab squared. And then we have b cubed. Now I want you to look at a pattern if you haven't already spotted this. Do you see Pythagorean's theorem? Do you see how at the very top we had 1 and 1? And when we went to our first row, that's the first multiplication of the binomial, we have 1 and 1. Do you see how that's similar to this row right here? And then on the next row it goes 1, 2, 1. Well, look what happens when we multiply again. 1, 2, 1. And the third row, see, when we have them, 3 of them being multiplied. Third row, 1, 3, 3, 1. Look at our coefficients. 1, 3, 3, 1. So now on the fourth row, if we look right here, in the fourth row, 1, 4, 6, 4, 1. 1, 4, we know it's all pluses, 6, 4, 1. Okay, now, what do you notice about the pattern of the A? Do you see how here it's just to the first? That was to the first. Here, this is to the second. We start out with a squared, and then it goes a to the first, and then there's no a value there. The next one it's to the third, it starts with a cubed, a second, a to the first, and then no a. So this being to the fourth, we know that a would start 4, then it goes down 3, 2, 1, and then there's no a value there. Now do you notice on the b that it starts at the last term and goes 2, 1, nothing. 3, 2, 1, nothing. So this would be 4, 3, 2, 1, nothing. Do you see the shortcut? If you're in class, I kind of trick you into finding the shortcut. So I hope that you were there. You'll remember it better that way. But on here, I'm just teaching it. Identify the patterns of the expanded power. What do you notice about the exponents? So that's how they went down in order, and that they started out with whatever that n is. So it would be a to the n plus a to the n minus 1 plus a to the n minus 2 plus a to the, and so on. What do you notice about the exponents of b? B starts out over here with no value, does it? It's b to the 0, so it'd be b, gosh, what would that be? B to the n, where did I put it? Oh, I put b to the 0, then b to the plus 1, then b to the plus 2, and clear out until it runs out. So yeah, it's to the 0th power, and then b to the plus 1. Okay. What is the sum of the exponents of each term? Well, the sum of your exponents, like up here in this term, the sum of the exponents is a squared for that term. Sum of these exponents is 2. Sum of this is 2. So down to 4. There's 4. 3 and 1 is 4. 2 and 2 is 4. 1 and 3 is 4, and 4. Okay, so they always add up to whatever your row is. What is the pattern of the coefficients of the terms? It follows the Pascal's triangle pattern. Exactly off the Pascal's triangle. Okay. In the expanded powers, a plus b to the n, if you replace a with l and b with r, then the terms describe the lefts and rights in the paths of each node. Okay? So let's have some fun with this one. Describe the paths of each node in row 4 by using the expanded form of L plus R to the 4th. So pretend that's like the A. So it would be L to the 4, then L to the 3, R to the 1, because they've got to add up to 4. L to the 2, R to the 2. L to the 1, R to the 3, and now it'd be L to the 0, so it's R to the 4. So in other words, the different paths for the nodules, or the nodes in row 4, is 4 lefts, 3 lefts, 1 right, 2 lefts, 2 right, 1 left, 3 rights, and 0 lefts, 4 rights. And that's the paths to each nodule in row 4. Okay? So let's look at it. The first nodule, we go down the path, the first nodule in row 4, left, 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 is right there. Okay? Now, we could get to it with 3 lefts and 1 right. So on the next one, we would go 3 lefts, 1 right. That gets us to that nodule. Okay? Or we could do 1 right and 3 lefts. or a left, a right, and two lefts. So see, in this first one, it's 4 lefts. L4, which could be written only in one way. L, 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 L. The next one, 4, 1, is L3, R1. So you could get there by going that way, or this way, or this way, or this way. So you have to show all the different patterns of it. Does that make sense? It's kind of hard to say, but what you're wanting to do is see your patterns there that you could have. On the next one, it's L2, R2. So we just need to run all the different possibilities of that one. Okay? And there is a pattern here as well. So hang with me. Here we go. We could go left, left, right, right. We could go left, right, left, right. Or we could go right, left, left, right, right, left, right, left. What's another one? Right, right, left, left. Or we could go left, right, right, left. Okay? Now, the third nodule. The third one is 1 left and 3 rights. So see how we're going right along with the nodules here. Each one, like I said, each one in row 4 is represented by these. So each one has their path here. So now here we go. 1 left, 3 rights. And all the different ways that you can write that. Okay. Next one, it has just 4 rights. So it can be written right, 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 right. Okay, now the one thing that I don't want you to miss on this is take a look at what the 4th row, the numbers in the 4th row were for that triangle. 4th row, do you see how the numbers are 1, 4, 6, 4, 1? Let's just write those down. 1, 4, 6, 4, 1. How many different combinations go for left? Just 1. How many combinations go with 3 lefts and 1 right? 1, 2, 3, 4. How many combinations can have 2 lefts and 2 rights? 1, 2, 3, 4, 5, 6. How many combinations could have 4, could have 1 left and 3 rights? There's 4 combinations, and 1 combination has all rights. Okay? So how many terms are in the expanded form a plus b to the n? Well, if we think about this, this was the 4th row, correct? And how many terms do we have in that 4th row? If you said 5 terms, you're right. So there would be n plus 1. That's the number of terms in the row. Check it out and go make sure that it works. Without expanding the power, what is the middle term of ab to the 6th? Explain how you found your answer. So let's go. 6th row, middle term. Okay? So the first thing is that we would go down Pascal's triangle until you get to your 6th row. It's going to be the 6th row, it's the middle one, so it's 1, 2, 3. Gotta see if I agree that that's the middle term. Doesn't look right. 1, 2, 3, 4. That's the term that it would be. The middle one is the fourth one. Okay? That would be your middle, because there's going to be 7 terms, so it's right in the middle. It's the fourth term in the 6th row. Okay? Now explain. Oh, they want us to go ahead and expand without giving the power. So we're going to have A would be 6 in the first term of that row. We're going to the fourth term, so it would be A would go 6, 5, 4, 3. Now we know that B and A have to add up to 6, just like we had all of these exponents in this row add up to 4. All of these have to add up to 6, so it would be B to the third. And now we just look back at what you got for your middle one on that row, and I would think that you would have 20. That's what I've got on mine. So it would be a 20 in the front because of the number that you have in that middle row there. Okay? So it would be 20, A cubed, B cubed. Without expanding power, what is the first term of A to the 15th? Or A plus B to the 15th. So again, first term in the 15th row. Well, we know the first term in any row is 1. And we know that the A term would be to the 15 and B would be to the 0. Okay? So the first term in every row is going to be 1, A to the n. However many rows you have, that's how it'll be. Okay? The binomial theorem states that the connection between the terms expanded binomial and A plus B to the n and Pascal's triangle for any whole number in the binomial theorem right here is given by, here we go, we take whatever node it is in the Pascal's triangle and we hook it up with this at the highest degree and that at 0. And then this one builds as that one goes down, so that their degree is always equal to that n value. And you just take the nodes off of the Pascal's triangle. Really handy to do rather than multiplying those all out. Okay. Now, using the binomial theorem to expand a power. So this is where it comes in a little bit handy, is rather than have to set this up in a box or foil, we can now look at it and say, okay, this would be third row. And we can get our coefficients off the third row. So turn to your triangle. Third row is 1, 3, 3, 1. Now we know that it's going to be S to the third. Then it's going to go S2 and negative 2 squared. I'm sorry, not squared, to the first power. They're going to add up to the 3. Then it's going to go S1, negative 2, 2, and S0 and negative 2 to the third. Now we work that out. 1s cubed. Take it off this end of the paper. That'll be 1s cubed. Negative 2 times 3 would be negative 6s squared. Negative 2 squared is 4, times 3 is 12, so plus 12s to the first. And now negative 2 times 3 is negative 6. Whoops. I'm sorry, negative 8. Not negative 2 times 3, it's negative 2 cubed. Wow. Negative 2 times 2 is positive 4. Negative 2 times 3, negative 2 cubed. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. Whew. Thank you. Okay. So it's a little bit easier than having to FOIL and box for as long as we do. Okay, here they show it all expanded. You can fill in the blanks. They're just showing what I've done right here, right there. And then they give the answer right here so that you didn't have to squeeze it. Now let's go down and do this one. So the fifth row, turn back to your Pascal's triangle, and the fifth row, trying to find it in my stuff. I have it memorized, but I'm looking the wrong way. The fifth row is 1, 5, 10, 10, 5, 1. Okay, so that's the values in the fifth row. So now we can just put them down here in the expansion, fill in the blanks. So we go 1, 5, 10, 10, 5, 1. Now we take our x, it's the first one, so it'll be x the fifth, y to the 0, then 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. Okay, now we can simplify it. X to the fifth plus 5x 4y1 plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. Okay, follow the code. What do you notice about the signs in the terms of the expanded form of s to the s minus 2 to the third? If you look up here, I don't know if you even noticed the signs here. It goes positive, negative, positive, negative. Okay? Why does that happen? Well, if you notice, every other term, your negative 2 is either odd or it's even. So here it's even. Here it would be to the 0th power. So that would be even. Here it's odd and there it's odd. And remember to what we know about odd polynomials and the ability to carry on the negative. If the number 11 is written as a binomial, 10 plus 1, how can you use the binomial theorem to find 11 squared, 11 cubed, and 11 to the 4th? This is kind of handy. I don't like it for 11 squared because the second row is just basically, let me show it this way, 10 plus 1 squared. And my second row of the Pascal's triangle is 1, 2, and 1. So we take 10 squared and 1 to the 0, 10 to the first, 1 to the first, and then 10 to the 0, and 1 squared. Put parentheses on all these. And for 11 squared, it's a little tedious, but it shows you the pattern. 10 squared is 100 times 1 is 100. Anything to the 0th power is 1. 10 to the first times 2 is 20. Times 1 is 20. Plus 10 to the 0th is 1. 1 squared is 1. Times 1 is 1. So it's 121. So that one it's not real handy with. But if you end up needing to do 11 to the third, this will be 10 plus 1 cubed. Now our third row is 1, 3, 3, 1, right? 10 to the third. I'm not going to put 1 to the 0. We don't need that. 10 squared times 1 to the first. Don't really need that, but 10 to the first 1 to the second, and 1 to the third. Now we add all those together. So we have 1,000. We have 3 times 10 squared is 300 times the 1. 3 times 10 is 30 times 1. And then 1 times 1 times 1 times 1. So we get 13,131. What are you noticing in these numbers even? Yeah, go ahead and show 11 to the 4th, expand it out. You'll know if you have the right answer because the answer will be 14641. Okay? But show it expanded how you get it using the binomial theorem. Okay, this is the practice when you come into class. We're going to do several of these. If you miss class, you definitely need to come in and practice this or practice with someone that was in class. Okay, thank you very much.